As we discussed in our video introduction to this series, we have a reproducibility problem in research. What does that mean? It means that when others try and do the same experiments as those that have been published in another time, in another place, they often don't get the same result. There are a number of reasons this could happen, but some of them have to do with how we write up and report on our work. Therefore, analysis and writing is the topic of this module in our series on enhancing research reproducibility. When I was in college, I specifically gravitated towards classes with tests, not papers. I hated writing. I also didn't think it would be an important part of my job. Boy, was I wrong. Are you a scientist? Guess what? You're also a writer. Being able to communicate your work to others is a necessary component of all scientific efforts. How else will other scientists be able to replicate your work to see if your results are robust? How else will they be able to build on it to advance knowledge? How else will the general public know about it? You're going to need to be able to write grants. You're going to need to be able to write papers. You're also going to need to know how to write memos and emails and IRB applications and progress reports and more. You may view these efforts as chores that need to be tolerated in order to do science, but you're wrong. They're just as important as other aspects of your work. Too often, scientists put all the emphasis on getting published. They care only, or at least mostly, that their paper's accepted and printed in a journal that they care about. That's unfortunately the wrong focus. I'm not trying to make light of the requirement that many of you have to publish or perish, but as scientists, we have to acknowledge that what we really should care about is getting our work out there in such a way that people use it productively to make their own advances. We want our work to help all of us move forward in some way. These days, even our metrics are recognizing this fact. In the past, we cared about the impact factor, the journals in which we were published. These days, more people are touting the H factor, which takes into account not only how often you were published and in what journals, but how often your individual papers are cited. Will they be cited because they had the most important work or because they were well written? Don't kid yourself. Both will come into play. There are two main reasons you're going to want to really care about your analysis and reporting. The first is to make sure that people actually read your work. The second is so that when they read your work, they understand it correctly. There's so many published every day now that it would be simply impossible for anyone to read them all. It'd be impossible for anyone even to try and read all the papers in their own field of interest. It's never been more important, therefore, for scientists to become adept at getting important information across in every single aspect of their work. You've got to work on your titles, which may be the only thing most people see. You've got to work on your abstracts, which are likely what even interested people will read. You've got to work on writing tight, compelling introductions that frame your work well and explain why it's important. You've got to work on figures and tables to get your information out there in ways which will engage readers. Even more importantly, you've got to make sure that people who read your work get it right. Your methods have to be complete enough so that others can replicate and build on your work. Your results have to be reported in such a way to capture correctly what you found without leading people astray. Your discussions have to place your work in context appropriately without overselling your results. Even things like references are important. Give people what they need. Don't rely on sources you can't trust. And as you read and write about research, one of the most important things you're going to have to do is consider whether it was powered correctly and whether its statistics are valid. Are the results statistically significant? Was the sample size large enough? What's a p-value? These are such critical questions that we're going to spend 3 whole episodes on them. Too often, research is done on too few participants, or animals, or even cells, and then the results are broadcast as if they're definitive and paradigm changing. People think that a p less than 0.05 means truth. That's so not the case. We're going to discuss why. If you make sure your work is valid and then present it in a way that makes sure it gets read and understood correctly, it's likely that your research will be reproducible in the future. It's likely that your results will be known and stand up over time. It's likely that your findings will be closer to what we believe to be truth. And that's what we all want, isn't it? This training module is part of a series funded by the National Institutes of Health.